All right, so let's get started talking about JPA. Let's see, where are we? Let's go into 2018, and let's go into fall, and let's go into section 1, and let's create a brand new application. And I believe the name, let's create maybe JPA fall 2018. So it's going to create a brand new application. And let's open it up with our Spring tool. Let's do import, and it's somewhere in here, existing Maven project. And it's, let's see, where are you? Januzzi, CS5200, fall, section 1, there it is. Let's open that up. And there it is. And let's make sure that this is running. Maven clean install. OK, so it builds. Looks like it's building. All right, so first of all, we'll need a couple of dependencies. That one of them is make sure that we are using the MySQL connector so that we connect into a database. And also, we'll need to install the JPA libraries. All right, so let's do that. We'll need that. I'm just going to copy it from another project. I think I never remember the configuration. But I'll copy from somebody else's POM. Basically, these are the two dependencies that we'll need. I'll copy that. Close all. So if you go into your POM file, you can add that dependency. Let's see, dependencies. Yeah, right here. Under the dependencies, we're going to add those two things. So one of them allows me to connect to the MySQL database, and the other one installs the JPA library. Once we've done that, we're also going to configure the connection to the database. So the way we connected to the database using JDBC, we were deliberately creating a connection ourselves, right? We were loading the class. We were providing the URL to the database, and we mentioned that typically you wouldn't do that. Instead, you would configure that separately in a different file, and perhaps read that as a property that is configurable, so that you wouldn't have to actually recompile the file if you wanted to change the vendor, right? Well, we're going to be using that technique. Additionally, we're going to be using a more modern, a more powerful version of JDBC underneath, right, which supports features such as pooling, connection pooling. Right? So instead of us managing the connections ourselves, right, instead what we're going to do is we're going to delegate that to a server. The server is going to, at runtime, right, it's going to, when it boots up, is going to create the connections for us, and it's going to have them in a pool that's going to manage it itself. We're not going to manage it ourselves, okay? You can configure it so that it responds to load throughout the day, right? So, for instance, if there's more load during the day, you can configure so that it starts with maybe 10 connections at the beginning of the day, and as you consume those connections. New connections are instantiated and added to the pool, right? And so the pool can grow, as folks come back from work and start browsing and whatnot, right? You can add more connections to that pool. And as everybody goes to sleep and the load diminishes, the pools are removed from the pool, right? So that you don't need any more connections. So all that is going to happen for us automatically, right? And it can be configured in a resource file That's right here, application properties. Right now it's empty. So let's grab one from another example that I have here. Here's one. I'll just copy that, and I'll paste it in here. And let's talk about it real quick. So this properties file is going to configure the URL connection where we're going to be connecting to. In this case, is CS5200 fall 2018. Actually, let's create a different one. We'll say maybe I'll call it JPA fall 2018. We'll have to create that. Username and password CS5200. DDL-auto equal update. This means that we're not even going to have to create the schema. Okay, typically you would have to create the tables, you would have to create the foreign keys, the primary keys. We're not even going to have to do that, right? What JPA is going to do for us is going to look at the classes, the Java classes, is going to make a best guess of what the schema should be, right? So if it'll guess by default that the name of the class will be the name of the table. It will guess that our fields, ID, first name, last name, whatnot, right? Those will be the names of the fields. It'll guess that strings is a varchar, that a date is a date or timestamp, right? And integers, whatnot. So it'll make a best guess of what the schema is, right? Also, if you have one class having a list or collection of others, right? It'll make a guess that those are two separate tables, and that one of them has a weak side and a strong side. It'll have a foreign key on one and pointing to a primary key to the other, right? It'll do the mapping, right? That's the whole point, that there is a mapping between the objects, the object world, and the relational world, right? It's the ORMs, object relational mapping. Okay. So that's what this allows us to do. You can turn it off. You can say none, meaning do not do that. There's a create. Create will create it for us from scratch. Update will create and will update, meaning once it's created, if you make changes to your fields, if you add new fields or you rename a field, whatnot, right? It will rename them for you. In create, if you say instead of update, you say create. Every time you restart the server, it will blow away your database. Right? It will recreate it from scratch, which is very inconvenient if you have data in there, right? You don't want it to drop the table, right, if you already have data in there. Update creates if it doesn't exist, but once it creates it, it'll make a best guess that if you add a new field, it'll do an alter as opposed to drop the table. Right? It'll do an alter, add the field, or change the data type and whatnot. Right? Make a best guess. Obviously, this feature you want in production, you want to turn it off. Right? Once you've settled on the schema and you know that that's the schema you want to keep, right? You turn this this feature off. Right? In production, you don't want to have to be modifying. This is only useful in development mode, right? When you're developing and it's very convenient as you go. Obviously, if the database already exists, right? It's a legacy system. You're not starting from scratch. If you're starting from scratch, this is great, right? But if it's a database that already exists, obviously you would turn this off. Right? You never want to modify a schema that is already it's in play, that it's already been used for years. You just want to map it. Right? You don't want to have it created for you. A couple other things in development, you can ask that when JPA will send the create, the updates, the inserts, the select statements for us underneath, and oftentimes it's very useful to see what JPA is actually, what commands is actually using, right? So we can turn that on. Which is great in development mode, right? You want to see exactly what commands are being used, the SQL commands that are being sent to the database to interact with it. This is useful. Oftentimes, we'll try to make some modifications, some optimizations perhaps, on some queries, as you like to know what is being used. Also, the naming strategy. You can configure the naming strategy so that, for instance, in Java, Java is case sensitive, right? So typically, your naming convention in Java is to use perhaps camel cases for your variable names, yes? But in relational databases, in SQL, it's case insensitive, right? So if you have a very nice naming convention in Java where you have camel cases and you have some of the variables are some of the letters are capital, that's going to completely be lost on the SQL side. So this strategy, what it does is that it'll do a conversion, right? It'll replace all the capital letters with underscore and then the letter, right? So for instance, first name in Java, where n is capital, will be converted to first underscore name in the SQL side, right? So you can turn that on as well. Other things is that depending on your version of SQL that they're using, you can also configure the dialect, right? The version of the SQL that you want to use, right? Again, all this is configurable for all vendors, right? So that your your source code will be oblivion, right? It won't care what the underlying infrastructure is. It's all configurable outside. Make sense? And there's tons and tons of other configuration that goes beyond our time here. Anyway, so this is expecting to connect to this database. I don't believe it exists. Let's go over to our SQL, and let's create a schema for this, and we'll call it JPA Fall 2018. Apply, and it creates it. Close. So there it is. And right now it's empty. There's nothing in it. There are no tables. All right, excellent. So I believe we're ready to get started. Let's talk about modeling and how the mapping occurs. Okay. All right. So let's talk about modeling. All right. So we created a project. We configured it. Here are the dependencies, right? If you want to copy and paste in there. Let's go back to the example we've been using all semester, right? So we have faculty, students, courses, sections, enrollments, okay? And this is what it might look like. You have a base class user, and you have two users that are inheriting from user, faculties and students. So we'll talk about inheritance, a little bit about inheritance today, but more in depth a little later. There's a whole lecture on inheritance. We'll talk about that. There's a couple of one-to-many here. Right, faculty has many courses has many sections. Notice there's also a mapping in here as well. Enrollment looks like it's a mapping between students and sections. So there's plenty of things here that can keep us busy here. How do we map this? How do we model this in object-oriented world? So let's start with a user. Let's create a model for this. Let's see. Let's go back here to our project and. We'll create everything under the package that it created for us. Notice that it created a package for us called com.example.jpa fall 2018. See that? Right? And under there is the entry to our application. There it is, our demo application. You can rename all this, obviously. You can rename the packages and whatnot. But for this magic of JPA to work, you have to be within a particular package, right? As far as this application is concerned, this is the root package of the application, okay? And under that package, it will be aware of certain things, right? So that only if inside of this package, it will be aware that certain classes have to be treated specifically. It has to have certain behaviors. For instance, our Java classes are not going to be just plain old Java classes, right? Although they'll look like them, right? They're going to be certain annotations that say, hey, I want this to be mapped to a class, right? So for that to work, the project has already been configured that it would live under this, that it has to live under that package. So under here, let's create a new class. And we'll put it under another package called models. And here we'll say user. So that's our new class. There it is. Okay. And here we'll have a couple of fields. Let's start off with these three fields. And let's paste them in there. Notice that we're following good practice. These are all private, and presumably these will also have all sorts of setters and getters. Setter generate setters and getters for all of them. After the last one, yeah. There we go. All right, so it created it. Not sure why the indentation. All right, excellent. So there we go. So this is a plain Java object, right? It's what we oftentimes refer to as a POJO. And there's nothing interesting about it, but we're going to make it interesting, right? The way we're going to annotate, the way we're going to let it know to use JPA to do the mapping between our object world and the relational world is that we're going to annotate it. Right? We'll annotate it with the following annotation entity. Right? If we hover over it, we can see where it comes from. Notice that it doesn't find it. Wait, what? Oh, I probably need to update the project. Maven, update the project. I made changes to the POM. Right? Probably Maven wasn't aware of the changes there. Let's try it again. All right, now it finds it. All right, notice that it's suggesting a couple of annotations. The org.hibernate.annotations is the implementation of this annotation, right? Hibernate, underneath, we're using Hibernate's implementation of that annotation, right? But we don't want to compile against a particular implementation. Instead, we're going to compile against the API, right? It's an interface. And the interface lives under the JPA package. And the JPA package is this one, javax.persistence. And so javax persistence contains all the libraries, right, of the JPA libraries, okay? All the classes and implementation. Well, not the implementation. The implementation is Hibernate implements them. All right? Everybody okay? All right, so that's enough. Right now, that's enough to map it to a table. Actually, we need one more thing. We need to be able to tell it how is this going to be uniquely identified. Right? What is the primary key? We could use a username to be its unique identifier. Instead, I'm going to use another field. I'm going to create a brand new field, private int ID. Right? And we're going to use this as a unique identifier. Right? Only because I want to show you another feature. And let's create the setter and getter for this one as well. Okay, we created a setter and getter. Very good. So one of the things that we're going to tell JPA that this is the primary key. Right? It's a unique identifier, and this is how we're going to make sure that this is unique. So to do that, we're going to use the annotation @ID, which is also part of the JPA library. If you load, there it is, javax persistence ID. There we go. And we can configure it. We can configure it and say that, for instance, just as it stands, we would be responsible for generating and making sure that that ID is unique. All right? We can have additional configurations to say, hey, I don't want to handle any of this modifier. For instance, I would like to use MySQL's auto increment feature, for instance, right? And each vendor uses different mechanisms to have uniqueness. For instance, Oracle uses sequences, right? That you can draw from a unique identifier that has been already generated from a sequence. So there's different strategies on generating unique identifiers. Right? And each strategy has its own name, a very specific name. So to do that, we can annotate it. Additionally, we can say that this is a generated value. Right? So meaning I don't want to have to handle this. Instead, I want to delegate this to the database to generate the value for me. And I need to specify what strategy I want to use. Is it a sequence table that I need to draw that from? Is it an auto increment? Do you want me to just incrementally generate a number for you? So this can be configured to use this particular strategy from a well-known set of strategies: auto, identity, sequence, and table. You'd think it would be auto, but it's actually identity. Identity is the one that maps to auto increment, right? So let's choose that. All right, I think that's enough. Let's take a look at this. If the database is right here, and notice that it doesn't yet have any tables. It's pristine. Can we close other tabs? Okay, that's the schema. We generate the schema. So let's rebuild this, just to make sure that it doesn't blow away. Let's refresh, making sure that we didn't break anything. All right, notice that a table was created for us, right? We rebuilt the project, and it created a user table that wasn't there before, right? We didn't generate this at the command line, and it has the fields that were listed on the Java side. Notice that we have the ID, first name, last name, password, and username. Notice the naming convention, right? It used the underscore instead of the camel casing. And we can take a look at the structure of the table to see what it used to create it. Right? Notice that it created the ID, first name, last name, password, username. Notice that it's using 255 for the varchar. That too can be configured, but that's the default. Right? This is the best guess of what you want. Right? For instance, the name of the table by default is based on the name of the class, right? But you can configure that as well. It says, well, no, I don't want to be called user, right? Perhaps a better name it would be users, as in plural, right? Because in SQL, it's common to use a plural version for the names of the tables, right? But in Java, typically it's a singular to use for the names of the classes. Right? That can be configured. Also, the names of the fields were also generated by a best guess, right, based on the names of the fields themselves. But that too could be overwritten. Right? You can say, well, no, use this specific name. Right? Maybe you want to use an acronym. Maybe your company has a naming convention, right? And so you can override that as well. So this is the minimum configuration that you would need, right? Providing the entity, and then providing the identifier. Right, that's the minimum configuration. Everybody okay? All right. Yes?
Sorry for jumping ahead, but I'm just curious about either constructor, your Java class, and why it's the case.
There's no constructor?
Yeah.
Actually, there is, right? The default constructor is provided for you. The no argument constructor is provided for you. Only when you when you overload it and provide an additional constructor, then it won't create one for you, and you have to explicitly create one. Yeah, it's assumed. So, for instance, you can call new user, right? So that constructor is given to you for free. Yes.
What's the use of the annotation of entity that if we call it from the Hibernate import that we have called using the Java Express?
Oh no, you could use that, the Hibernate implementation, but then that marries you. It forces you to only use that provider. Right? There's other providers other than Hibernate that implement the JPA interface, right? That are competing. Although Hibernate is kind of the standard, but there are other vendors that also implement the JPA standard. All right, so we created the user model, created the entity and the strategy. Let's talk about how we could interact with it.